Now it's time to ask which strategy is more accurate. As we see, the front-end strategy depends on the highest place value or the end digit, and it ignores anything else. Meanwhile, rounding depends on the location on the number line on the 120 chart, so that it gives more accurate estimation and closer numbers to the actual value. To prove all of this, we will find the estimated sum and the estimated difference for different equations. So here we can use our estimation to get the estimated sum. The first example, 113 plus 282. I want to get the estimated sum using the front-end estimation. So here I will estimate the two addends and add them together to get the estimated sum. The first addend is 113. Using the front-end estimation, I will look only at the last digit or the end digit, which is 100, and I will replace all neighbors by zeros, so it will be estimated to be 100. Plus, the second addend is 282. In the front-end estimation, as we said, I have here 3 digits. It looks only to the last digit or the highest place value, which is 2, and I will replace all of digits to zeros besides. So here I have 100 plus 200, and now it's so easy to add them mentally together to be 300. So the estimated sum here is 300, and we have to differentiate between the actual sum and the estimated sum. It's not the exact sum, but it is the estimated, because it's a sum of the estimated two addends. Here, I will use the rounding strategy to estimate the sum or to get the estimated sum. Here I have 113. I will round it to the nearest 100. So our leading digit here is 100. In the front-end estimation, I ignored anything except the end digit. But here, the leading digit can't take the decision alone. It will ask its neighbor. 1 is weak number, so it can't hold the 1, so it will be 100 as it is. Plus 282 will be rounded here to what? Our leading digit is 100, and it will ask for its neighbor's help. 8 is strong, so it will help our leading digit to be 1 more, so it will be 300. Now I have 100 plus 300, which equals, if we make it mentally, it will equal 400. And 400 here is the estimated sum, not the exact sum. To compare between them, you will find that from front-end estimation, I get the sum is 300, and from the rounding, we got 400, and it's a very big difference between them. The actual sum is what? 113 plus 282. Here I have 1s, 10s, 100, and 1s, 10s, 100. To get the actual sum, I will add the ones first together. 3 plus 2 equals 5, and 1 plus 8 equals 9. 1 plus 2 equals 3. So here, if we compare the actual sum, which is 395, with the two estimated sums from the two ways of estimation, we will find that 395 is very close to 400 than 300, so that using the rounding strategy is more accurate. Find the estimated difference. Here I will not get the exact difference, but I will get the estimated using the two strategies of estimation we studied. The first one will be using the front-end estimation. Here I have 89 minus 31. I will estimate the first number and estimate the second subtrahend to get the difference. So here 89 will be estimated to be what? In the front end, we said that we ignore anything except the highest place value or the end. Here I have 89, it will be 80 minus 31. In the front end estimation, we don't look at any digit except the end one, which is 3, so it will be 30, and it will equal 80 minus 30. It's so easy now to make it equal 50. If we get the estimated difference using the second strategy, which is rounding, here I will round the first minuend and the subtrahend to get the difference. So here I have 89. To estimate it to the nearest tenth, our leading digit here is the tenth. It can't take the decision itself like we did in the front end estimation, so it will ask for its neighbor help. Its neighbor is 9, it's very strong, so it will help 8 tenths to be rounded up to be 90. Minus, we will estimate or we will round the second number, which is 31. I have here ones and tenths. Our leading digit is the 10th digit, which is 3. It can't take the decision alone. 1 will take the decision. 1 here is weak, so it can't help our leading digit, so it will be as it is 30. And it equal what? Now it is so easy to say that 90 minus 30 equals 60. So here, from the front end estimation, we get the estimated difference, which is 50, and from rounding, we get the estimated difference, which is 60. And I have very big difference between the two values. So we will get the actual difference. To get the actual difference, I will subtract ones first. I have here 9 minus 1 equals 8, and 8 minus 3, and it equals 5. So the actual difference will be 58. If we compare the 58 with 60 and 50, we will find that it's closer to 60 than 50. So that rounding estimation gives us more accurate result than the front end estimation. So that rounding is more accurate than the front end way. Write your estimation using a front end strategy, then compare with actual answer if it is near or far. The first example is 23 plus 56. Here, to get the actual sum, I will add the ones digits first together. 3 plus 6 equals 9, and 2 plus 5 equals 7. So the actual sum is 79. And to use the front end strategy to get the estimated sum, I will estimate 23 using the front end. In the front end, we look at the last or the end digit only, and we ignore anything else. So 23 will be estimated to be 20, and 56 will be 50. And now it's so easy to say that 20 plus 50 equals 70. If we compare 70 and 79, they will be far. So we will select they will be far. Second example, 86 minus 43. To get the actual difference here, I will say that 6 minus 3 equals 3, and 8 minus 4 equals 4. So the difference will be 43. To use the front end strategy to estimate, I will estimate 86 by 80, because our leading digit here is 8, so it will be 80, and in 43 our leading digit is 4, so it will be estimated to be 40. And here 80 minus 40 equals 40. If we compared 40 and the actual difference, which is 43, they will find that they are near to each other, so here I will select they are near. Number 2, write your estimation using rounding strategies and compare with actual answer if it is near or far. I have here the same example, 23 plus 56, and we said that the actual sum equals 79. If we rounded each number to get the estimated sum, so here 23 will be rounded to be 20, because 3 is a weak number, so the tenth will be as it is 20. and 56 will be rounded to be 60 because 6 here is a strong number, so it will add 110 to the 510, so it will be 60. So now the estimated sum is 20 plus 60 and it equals 80. If we compared 80 and 79, they are too near to each other, so we will select they will be near. And here if I have 86 minus 43, it is the same example like up, and the actual difference is 43 as we said. And if we rounded the first number, 86 will be rounded to be 90 because 6 is a strong number, so I will add one more to 8 to be 90. And 43 will be rounded down to be 40 because 3 is weak number, so the tens will be as it is, 4 tenths or 40. And now it's so easy to say that 90 minus 40 equals 50. And if we compare the 50 and the 43, they are far from each other, and my estimated difference is so far from the actual, so here I will select they are far. Another example, write your estimation using front-end strategies and compare with actual answer if it is near or far. Here I have 3 digits number plus 3 digits number. I have 523 plus 426. Here I will add the ones digit together, then the tenths, then the hundred. To get the actual sum, I will say that 3 plus 6 equals 9, and 2 plus 2 equals 4, and 5 plus 4 equals 9. So the sum here is 949. I will use the front end strategy, and here I will look only at the last digit or the end digit, and I will ignore anything else. So my leading digit here is 500, so 523 will be estimated by 500, and 426 will be estimated to be 400. And now 500 plus 400 equals 900. So our estimated sum is 900. And if we compare the 900 with the actual sum, which is 949, they will be far from each other. So we will select far. And here 367 minus 132, if we try to get the actual difference, we will say that 7 minus 2 equals 5, and 6 minus 3 equals 3, and 300 minus 100 equals 200. So the actual difference here is 235. And I will estimate each number using the front end estimation. So 367 will be estimated to be 300. Because our leading digit is the 3, it will be as it is, and it will be 300. And here I have 132, it will be estimated to be 100, because I will put the leading digit or the last digit as it is, and anything else by 0. And now 300 minus 100, it will be 200. And here if I compare the 235, which is the estimated difference, with the actual difference, which is 200, we will find that they are far from each other. So here I will select the far. Here I will use the rounding strategy to estimate, and I will compare the estimated answer with the actual answer I will get. Here it's the same example, 523 plus 426. We said that the actual sum is 949, and here we will round each number to get the estimated sum. So here 523 will be rounded down to be 500 because 2 is weak number, but 426 will be 400 because also 2 is weak number. So here 500 plus 400 will be 900, and our estimated sum is 900 as we get from the first way which is front-end estimation. So here if we compare the two numbers together, they will find that they are far. So here we will select far. Another example here, 367 minus 132. We said that the actual difference from up it equals 235, and I will round each number to get the estimated difference. So here 367 will be rounded to be 400 because 6 is a strong number, so it will add 1 to the 300. And 132 will be rounded down to be 100 only because 3 is weak number, so it will be rounded down to be 100. And now to get the estimated difference, we will say that 400 minus 100 equals 300. And if we compare between the actual difference and the estimated difference, we will find that they are far from each other, so here I will select they are far. Estimate using both front-end and rounding strategies and decide which one is more accurate. So first I will get the actual sum. Here I have 254 plus 327. I will use my place value mat to represent each number. Here the first number is 254. I will represent the 4 small squares for 4 ones and 5 bars for 5 tens and 2 blocks or 2 flat for the 200. And I will represent also the second addend, which is 327. I will draw 7 small squares for 7 ones and 2 bars for the 2 tens and 3 blocks for the 300. And to get the answer, here I will find that once they are more than 9 ones, so we will regroup. So here I will regroup 10 ones to make 1 10. So 1 2 2 3 4 5 6 7 8 9 and 10, and I will regroup them together to make 1 new 10. So they will be moved to make me 1 bar here in the tens. And now I will add them together. So here I have only 1 in ones, and how many tens I have here? 1 2 3 4 5 6 7 8. So they are 8 tens now. And how many hundreds? 1 2 3 4 and 5. So the actual sum now is 581. And now I will use the first strategy, which is front-end estimation. I will estimate using the front end, and as we said here, I will look at the last digit or the 100 digit. So 254 will be estimated to be 200, and 324 I will look at the last digit only, which is 300, and it will be estimated to be 300. And the estimated sum now is 500. And if we rounded each number to get the estimated sum, we will round 254. We will round it up to be 300 because 5 here is a strong number, so it will add 1 more to the 200 to be 300. And we will round 327 down to be 300. And now 300 plus 300, it equals 600. Here I will compare between the two estimated sums. Here I have 600, and I have from the front end strategy 500, and you will find that 600 is more near to 581 than 500. So that rounding strategy is more accurate, and it gives me more accurate number to the actual 5.